How many times will I say that I'll use swim link? Please, can someone comment on the group chat that will make use of the same link? Copy this link and paste it there. I don't know why people keep asking he has not gotten the link for the class. I don't understand what they mean by that. So someone should please comment on the group chat, the link for the meeting. Someone should comment on the group chat, please. Thank you. So welcome once again, everyone, and um, I hope we are doing well. Has anyone done that? Emmanuel, Titiola, anybody? Um, thank you. Okay. Okay. All right. So welcome everyone to today's class again, and we'll be looking at scalar vector. I don't know the number of persons that watched that very video on the dashboard. The reason why I usually send those videos is that it will help us to make the work easier for each and every one of us, right? That way we can cover more things within a short period of time. So that's one key thing about us making use of um, those dashboard. So that said, let's quickly go into scalar vectors. But my major goal today is resolution of vectors. So remember, as we all know, we have our, let me start with scalar quantities. Remember that scalar just has to do with, it has only magnitude. I can remember back then, if they want to insert, they'll be like a scalar quantity, which means you don't have any direction, right? So that's how we normally use it back then. We'll just say that this guy is a scalar quantity. Now that your video is on, you can do well to turn it off. So we have without just magnitude and without direction, right? And more like, for example, now if you are traveling, distance is a scalar quantity. Speed is also a scalar quantity. I can tell the man, okay, I'm traveling to Lagos, and just take me to Lagos. Okay, if I'm talking about taking me to Lagos, I'm giving that person direction. But I just enter. I will tell the man I want to drive at 60 km per hour without telling the man where I'm going to. That is scalar. You're telling the man the magnitude, the intensity at which he should move. Do you understand? But once you put your direction, okay, I want you to travel at 60 km per hour to Lagos. Now you've given that person a perspective in terms of the direction to know that yes, I'm moving to so and so place. I've given that person your direction. So, but for scalar quantities, there are key variables we should pay attention to when you're dealing with what scalar quantities. So basically, it has just what magnitude only. We know all of these things just to give us a context. Yeah, so it has magnitude only. If I'm describing this, it just needs only number and units. It just requires number and units to describe. Are you there? Number and units to be what? To be fully described. So these are the two key things you need. You can say 20 meter per second without you giving any direction, right? Even the amount, a lot of scalar quantities, energy, work, speed, pressure, all of those things are scalar quantity. They just need you to talk about what? Talk about the units and talk about the number. So examples include, we're going to write as much as possible. So we have your speed, you can have speed, you have mass, um, you can contribute as well so that it will be very fast. I know that everybody's following me. We have mass, we have energy, we have work, we have density. All of these things, they don't make reference to direction. We have density, we have pressure. Which other one am I forgetting, guys? We have pressure, we have distance. Yeah, distance is a scalar quantity. I know people sometimes confuse speed for velocity, right? But velocity is a scalar quantity, where the other guy, velocity is a vector quantity, while the other guy, which is your scalar, your velocity, speed, scalar, vector, velocity, a vector quantity, just like the name implies, right? So this is what you have for the scalar quantities. Now let's quickly look at our vector quantities and we'll move off to the major deal of what we have today. So for your velocity, or your vector rather, for vectors, what are those key things I need to describe my vector? So to fully describe a vector quantity, I have to speak about the magnitude and I have to speak about what the direction. So to describe it, to describe it, to describe a vector quantity, you must state the size and the direction. You must state size and direction. Now, what are those examples? So it should have a magnitude. It should have magnitude, and it should have direction. All right. So these are the key things you should have. An example of your vector quantities is displacement. Displacement is a vector quantity. Velocity is a vector quantity. Acceleration, we still keep into projection, your direction. Which other one can we talk about? I should have my momentum, 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 which is force times velocity, momentum. You can have your magnetic field strength. All right, so I leave others to you. Go check out the other remaining ones that we can talk about. Okay, yeah, let me also include weight as well. Let me include force, and then include weight. These are the ones I know most times questions might revolve around this. Yeah, so that's for that. Any questions so far? If you're with me, just give me a thumbs up. Let me know that all of us are on the same page. Give us a thumbs up so that I can proceed to the major deal. All right, thank you, Titiola. Thank you, Anointed. Yeah, Anointed, you keep asking about meeting link. We'll make use of the same meeting link. Pin it somewhere so you don't keep asking about meeting link. Is that okay? Yeah, confidence, are you following? Ferrami, are you there? Good. Eze, are you there as well? Please ensure that we are all together, right? So now, let's now focus on vectors now. That's the major key guy for today. Let's focus on vectors. Now, how do we represent vectors, right? So let me look at the representation of vectors. So we usually represent a vector. It's going to have an arrow just at the tip of it this way. Are we together? You can also have it. Let's say there's an object here. Let's say there's an object here as a tip. Now, the length of the vector, the length of the line gives you the magnitude, right? The length of this line will gives you the magnitude of the vector. So what am I saying? Because we'll be sketching. So the length of the line, the length of the line gives the magnitude of the vector. All right. So why the angle between the object and where it is acting? Let's say we have another vector acting this way. Are we together? Let's have another vector acting this way, in this direction. So that angle here, the angle gives you the direction. Are we together, guys? The angle here will give you the direction of the vector. So when they're asking for the direction of a vector, they are simply asking about the angle, right, between a particular vector and another vector. Right? Yeah, just that's the angle of the vector, So that's how to represent the vectors. But there's another key thing we want to know, which is our resultant vector. But for now, just know that length of the line will give you an insight into the magnitude of the vector. Does it make sense? So anytime you see that length of the line, that tells us that, okay, this is the magnitude of the vector. So another key thing we need to talk about is your resultant vector. So imagine that we have a particular object. We have a particular object. Let's say this is the object. And they will have different vectors acting on this object. Let's say we have a whole lot of them acting on this object. These are vectors. These are vectors acting on this object. A whole lot of them acting on this object. A whole lot of vectors. A whole lot of them acting on this object. Now, there are many of them. So, but we want a single vector. A single vector that will have same effect as these whole vectors, just one vector. Now we have plenty of them. Let's say we have 15 of them acting on a particular object. We seek just one vector that will act as a single resultant representing all the stuffs acting on these objects. Whether we have 30 of them, we need one single vector. And that single vector will have the same effect. Let's say out of all these whole vectors, we want to represent it with a single vector, and that single vector should have the same magnitude and direction that actually takes into cognizance the entire effect of the stuff. So let's say that we'll have one of them be represented this way, a single force, a single vector. So let this be my resultant vector. This is the resultant. What it means that all of these things acting here has been represented with just one line. And that one line is what we regard as our what? Our resultant vector. If that makes sense, can you give a thumbs up? Let me know you understood what I just said regarding your resultant vector. Yeah. Do you understand what I just said regarding your resultant vector? Okay. Yeah. No, so well done, Jeremy. Yeah. All right. Anointed. Good. Confidence. Were you the one that said you went for jam registration the last time? One of you, I don't know who that is. It Stephanie or you? I can't remember, but one of you. Confidence, was that you? It was you. Give me a thumbs up. Let me know. All right. So that's for your, okay. No. All right. Beautiful. So let's look at resultant vectors now. I've actually given a hint about your resultant vector. It was Stephanie. Okay. Okay. And she has not joined the class since then. Maybe she's still doing the registration since then. Does registration take 5 days now? Most probably it might. You know. All right. So let's look at our resultant vector right now. All right. So okay, I forgot to say something. And now the process of putting all of these things, bringing all these vectors now to become one vector is what we regard as what? Resolution of vectors. Does it make sense now? Bringing all of these guys together to become one vector is what we regard as what? The resolution of vectors. So the process of bringing those plenty vectors into one single resultant vector is what we regard as what? The resolution of vectors. And that resolution is the heart of everything we're going to be doing today when they are acting parallel, same direction, and the rest of them. So, but before then, let's get to understand what we mean by a resultant vector. So let's quickly put down resultant vector. Now, in your own terms, you can actually define a resultant vector because I've explained the concept and what it entails. I've already done that. But for some of us that might not be able to get the concept I gave, so let me quickly run through that as well. So a resultant vector is simply is the resolution of what or combination of what of two or more what vectors into a single vector. So you can put it down right away. I would prefer for us to be writing why I just go straight to solve it. That will save us time. So a resultant vector is the resolution of what or resolution or combination of two or more vectors into a single vector that has the same single vector such that, are we there? The single vector will have the same, so that the single vector has same effect as the that's the concept. So let's now look at something I think we should do first. I know some of you, it's been very long you did maths, but then I have to talk about your sine rule and your cosine rule. So there are different ways that vectors can act, especially two vectors. Now you can remember back in secondary school, the one that normally looks like this. You have a line like this. you have a vector going this way, we have a vector going this way. Sometimes you can have up to 5 of them, and they say you should resolve. How many of us can still remember this? If you can still remember it, can you give me a thumbs up? When you did something like this in secondary school, that you had to copy somebody, some of you. All right, so that's the resolution of your vector. Yeah, thank you for those who that didn't give me a thumbs up. It means I didn't do it in school. All right. All right. So two vectors can act as a body in different directions. That's a key concept. Now, I've talked about resultant vector. So let's look at the resolution of vectors now. How do we get a resultant vector, right? So when I mean resolution of vectors, remember I'm talking about what? Getting a resultant vector. So we can have 3 cases or about 4 cases because vectors can act in different directions. There are 4 different cases, in brackets looking for resultants. So different cases that we might need to look for the resultant vector. There are 3 different cases we might need to look for the resultant vector, right? So, and those cases are what we're looking at now. So sometimes you can have a case 1, when the vectors are acting, when two, I'm talking about for 2 vectors now. I've not entered that case where you have up to like 7 vectors acting together. So resolution of what? Of 2 vectors. So I think I should just put it right here that I'm talking about what? Of 2 vectors. So looking for the resultants for 2 vectors. So case 1, when the 2 vectors are acting in the same direction. When they are acting in the same direction. Now, the next case is case 2, when they are acting. So I'll just use 2 vectors acting in opposite direction. Now, for some textbooks, they will make it 4 cases, but for me, I think that the case 3 and the case 4 is almost the same thing because it has to do with when they are inclined at an angle. But for us to follow the process, and I will still explain why I said that case 3 and case 4 are almost the same thing. So 2 vectors acting 2 vectors acting at right angle to each other. In bracket, they are acting at 90 degrees to each other. In other words, they are perpendicular to each other. So if you don't say they are acting at right angle, but you can say that they are perpendicular to each other. I think that perpendicular is very important because based on the exam, you hear in perpendicular, right? That means we're talking about when they are what? Perpendicular to each other. All right, then the final case, which is case 4. So the case 4 now has to do with when they are inclined at an angle. 2 vectors inclined at an angle. And for this inclination, it can come in 2 ways. It can be obtuse angle, and it can be what? It can be what? Acute angle. So, science students, what is an obtuse angle? It can be acute angle, and it can be obtuse angle. Oh yeah, science students, over to you. What is an acute angle? What is an obtuse angle? Anybody? I should start calling names. Justice, over to you. Justice, what is an acute angle? Justice, what is an acute angle? Um, Ferrami, what is an obtuse angle? Titiola, what is an obtuse angle? Who again is on this call? Anointed, what is an obtuse angle? Nobody's talking. So I'll leave it us to. Are you sure you guys are in this class? Or we should just close it here?
An opposite angle is greater than
Okay.
90
90
degrees.
degree, but less than 180 degree.
Ferrami, when I asked you, you didn't answer. Allow anointed, right? So here you're talking
Sir,
about a particular. Okay, Titiola, over to you.
they didn't say acute angle, so I wanted to answer it.
Okay, well, I was acute. Okay, go ahead and answer. What
It
is
is
acute
less
angle?
than 90 degree.
Okay, less than 90 degrees. Okay, thank you. It's less than. I think I should be talking like Titiola now. Is it okay? So, so greater than 90 degrees. Titiola, you should be a chorister in your church. True of us.
False.
No, it's
Ah,
got to be.
that voice is wasting. All right, less than 90 degrees. All right. Yeah, greater than 90, less than 90, less than 90 degrees. All right. So remember that greater than 90, but less than 180, that should be your up to. So that's for case 4, right? So before I talk about the first case, let's talk about what we call a parallelogram law. Like, you know about your parallelogram, then you have the law at the back, right? That will help us to get the resultant. Okay, before then, let me talk about the first case. I'm skipping. Sorry about that. And that's against the rule of teaching. So you don't get confused. The order to which the information is presented determines how you guys will understand it. So let's look at case 1. So case 1, two vectors acting in same direction. See, by this time next year, I want to be coming to different matriculations. Anywhere, invite me on time. I want to be there. Hmm? Anywhere, I want to be there. Do you believe that is possible, right? Yeah, I want to be coming to different locations for different states for different matriculations. All right. So, but then we have to do the work. So two vectors are not just anyhow matriculation. I mean, into that course you want to study. I'm not talking about JAM gave you or the school gave you. I'm talking about that course you want, right? I'm coming for those matriculations. So two vectors. So if you want to see me, don't tell me that JAM gave you. I will not come. But if it's that course that you said you want to study, I'm going to be there. So two vectors acting in the same direction. Now, when they're acting in the same direction, let's assume that we'll have this is an object. I'll just be drawing circles this way. And let's say that this one is acting on the body this way and is acting in this direction. This is the arrow. And let's say I have the second one as well acting on this object and is also acting in this same direction. Now, let's say that this one is 5 Newton and this one is 3 Newton. So when two vectors are acting in the same direction, we add them together, right? So the resultant vector R, resultant vector, or let's make it this way so that it will be easier for us to generalize and have a specific formula for that. So let's say we have vector A and vector B. Let's say that vector A, let's use this arrow to show that these are vectors, right? These are vectors, these are vectors. So let's say that our A vector, let's say that it is equal to what? 3 Newton. Vector B, let's say it is equal to 5. The resultant vector would be equal to, since they're in the same direction, right? If they're acting in the same direction, we're going to add them together. Will give us the both of them added. So that the resultant vector should be equal to what? 3 plus 5. So that the resultant vector R is equal to what? 8 Newton. In which direction will it be acting? Since they are acting in the same direction, the resultant vector will as well be acting in that direction. Does that make sense? So our resultant vector as well, if I want to represent that, we can now have the object here. Now, let's say resultant vector still this way, acting in this direction, and the value at that point in time is what? 8 Newton. So you've seen that we've represented those single forces, so single vectors acting And that vector here is a force, right? So those single forces acting in different directions has been represented using a single force. And that single force happens to be your resultant force, right? Which is also a vector. So sometimes for vectors, we make use of forces because vector force is a vector. And in physics is more of statics and what dynamics, right? So that is what 8 Newton, which is your resultant vector. So hence, when two vectors are in the same directions, we do what? We'll add them together. So that's a concept you have to know at this point. So that one is very easy. So addition. Now for case two is when two vectors are acting in what? In different directions or opposite, not different, opposite direction. Now, case two vectors acting in opposite direction. You know that the vector, the first one is more like having a good friend, right? That's what we keep saying. Ensure that the friends you have, all of you are pursuing the same goal. So when you guys have the same goal, you come together, you achieve more. Are you seeing the gist right there now? So two good friends having the same drive, the same purpose, the same goal. You know, let me leave purpose. Purpose might be different, but then you have the same goal, you have the same desire and hunger. When you guys team up together, you add up and you achieve a lot. But now when you have a friend that, as you're talking about gaining admission into school or reading your book, the person is saying a different thing altogether. That means that you guys belong to case two because two of you are acting in opposite what directions. And when two friends are acting in opposite direction, this one is going to be dragging this one, and this guy is going to be dragging the other guy. And what will happen? The person that will win is the one that has more influence. And in several cases, which one wins? The good or the bad? In several cases, which one wins? Let's be truthful now. People in class, which one wins in several cases? Is it the good or the bad? Nobody wants to talk. Everybody is innocent. So now, the bad actually, yeah, completely. So let's see what happens right here. Yeah, the bad does because yeah, they have major sometimes because you know why it is easier because example, if I want to turn to a tout tomorrow, does it take anything? If I want to turn to a bad guy tomorrow, it doesn't cost me anything. The next thing I'm going to do is start from my hair. You know, from there, you know, one or two things. I put my earring and the rest, and I'm good to go. And I start doing what's up, nigga. Just under 30 minutes. I've changed automatically. So it's very easy to become and to turn to bad than to become good actually. So now when we have the acting in different direction, so we have this guy in this way, and then the other guy acting the other way. Now let me increase it because I said that the length has to do with um let's have this guy. Let's say this guy is acting in this direction, right? So now, in this case, what happens? Or I can even use the same place so that it doesn't look as if they must face in the opposite direction. We can have this guy. This guy is acting this way, and we can have this second guy acting the other way, right? But let's increase this guy a bit to show that he has more abito sheke. He has more power. All right. So let's have here to be A and here to be B. And I'm still using the same value. I said that in the first one that A was equal to 3, right? A was equal 3 Newton, and that B, okay, I think at this point I might need to interchange so that we have consistency across board when we'll be reading it. So this is B. All right, so A is equal to this and B is equal to 5 Newton. So the resultant at this point in time, they are acting in different direction. Like I said, the bad guy always have more influence because it's easier to learn, and B has more magnitude. So the one with more magnitude, you're going to subtract the smaller one from the bigger one because they are acting in opposite direction. So that the resultant is going to be equal to what? 5 minus 3. So resultant is equal to 2 Newton. Now, who will tell me which direction will this resultant vector take? What will be the direction of the resultant vector? Now we'll have the value of the resultant vector, which is 2 Newton. So we'll have that object. We'll have the resultant vector, which is 2 Newton. So who will tell me which direction will it go through? What will be the direction of the resultant vector? Direction to 5, to the 5. Exactly. It's going to take that same direction as 5. Always remember the friends I talked about. So the guy with more influence will cause the other guy to follow him. And that's what happens to resultant vector. So you should take the direction of 5 because 5 has more magnitude. So these are the two cases where an object or vectors are acting in different direction, in same direction, and when they are acting in opposite direction. Don't say different actually, because it can mean a lot of things. So same direction and opposite what direction. So when they are acting in same direction, we are adding the vectors together. When they are acting in opposite directions, we are doing what? We are having our what? Our subtraction. All right. For us to now consider case 3 and case 4, remember that case 3 and case 4 has to do with when they are inclined at an angle. Before I will say that, I want us to look at what we call the parallelogram law, right? Now, for case 3 and case 2, we have to learn about what? The parallelogram law. So we have case 3 and case 4. All right. To get the resultant vector in case 3 and case 4, and you know what case 3 is. To get the resultant vector for case 3 and 4, we use and apply the parallelogram law. We use and apply the parallelogram law, cosine rule, and your sine rule. So these are the concepts we'll be needing for us to be able to apply what? Our cosine, to find our resultant vector for case 3 and case 4. We should be able to apply our parallelogram law, cosine rule, and there's another thing I forgot. Do I know how to spell it? Pythagoras theorem. Oh yeah, English students, am I correct in that spelling? All right, thank you, Titela. And sine rule. Thank you, Anointed. Parallelogram law, cosine rule, Pythagoras theorem, and your what and your sine rule. So these are the concepts that we need for us to be able to understand our what do you call it, for case 3 and case 4. Remember, case 3 and case 4 is dependent on our ability to what? Apply our parallelogram law, cosine rule, Pythagoras theorem, and what? Your sine and what? Cosine rules. Now, what does this parallelogram law talk about? It's just saying that when I have that if you have the two vectors are represented by the adjacent sides of a parallelogram. Before I bite my tongue, if two sides of if two vectors are represented by the adjacent side of a parallelogram, then remember we can complete this guy this way. Sorry, let me give more space. Let me give more space. Susan, you're just joining the class now. The class that started by 10 a.m., you are joining by 11. And I know that you're not going to watch the recording as well. I'm not happy with you. Just take note. And I'm saying it in public so that you will know how heavy it is. Now,
Yeah, actually,
if don't worry, you explain later. In the court of law, you're going to explain. After now, you chat me up and explain yourself. But don't use voice note before you drop 10 minutes voice note for me. So we have. Why are you guys laughing? So we have this. Then we have this. Now, when two vectors are represented by, hope you're not feeling bad, Suzanne. I'm just doing that so that you know that I'm not happy with you. So now, but I know we are good. I know we are good. So now, when two sides of two vectors are represented by the adjacent side of a parallelogram, so let me complete that very parallelogram. Okay, thank you. You know, I see you guys as my siblings, so whatever thing my siblings will do, and I'll not be happy. That was so correct in love as well. So now you have completed it. So that if two sides of, let me move this our guy a little bit so he doesn't interfere with others. All right, good. So let's go ahead and complete it. So we'll have two sides. This is your parallelogram now. So we'll have this way. So it says that if two vectors are represented by the adjacent sides of a parallelogram, that the diagonal drawn from the center of two of them will give you the resultant vector. Now, let's say that these are the vectors now. We'll have the first one, having this arrow right here. We'll have the second vector. This is the second vector. They are represented by the what? The two adjacent sides of a what? Of a parallel. That is not the resultant. That's what the parallelogram law is talking about, right? So when you represent, if the adjacent sides of a parallelogram represents two vectors, right, that the diagonal drawn from the center of those two adjacent sides will give us the resultant of the parallelogram. All right, so let's quickly put that down, which is your parallelogram law. So let me copy this and move it down a little bit. Let's take it down a little bit. You should wait for us here, right? So that said, let's go ahead and start with our parallelogram law, which is the very first concept that we need to learn. And then I will teach you about the angles in a parallelogram. We are running out of time, but as it's burning in my heart, I want to finish at least this intro. Let me know that in our next class, we are just solving questions. So parallelogram law, which I've already explained, just for us to have a write-up on that. And I've already said it. The smart guys must have taken note of that by now. So this states that, well, all of us are smart anyway. Let me not say that again. This states that, right, if two vectors are represented by the adjacent side, is presented in magnitude actually. It's presented in magnitude and direction. It's presented in magnitude and direction. And direction by the adjacent sides If you guys are not writing this, no need. So I'll just be solving questions by the adjacent sides of of a parallelogram. Of a parallelogram, Roma. The resultant vector is the diagonal, right? Is the diagonal of the parallelogram drawn from a common point. And I've given the diagram already, drawn from a common point. Right? So that is for your resultant vector. All right. So it's just the diagonal. The resultant vector is the diagonal of the parallelogram drawn from a common what? From a common point. All right. So that said, this was a diagram that we used, and don't know how we entered inside here. Okay. Good. So I give an illustration now. Now that will give us our resultant vector. This is your parallelogram, as the case might be, and I represented them accordingly, as you can see right here. Right. So let's put the arrows very well so that it makes sense. So this is your arrow, 6 Newton right here. Then the other side is your 3 Newton. Hosanna, you're just joining, you're giving me thumbs up. This young man. Thumbs up for coming late or thumbs up for doing what? All right. So that's for that anyway. Welcome, by the way. But you're a funny young man. So this is 6 Newton here. And then this is 3 Newton. Let's just apply that. All right. So, and also remember that this place as well, in as much as my parallelogram is not parallelogramming, because they should be of the same height. But you can see that my own is not of the same height, right? They should actually be of the same height. So let me see what I can do so that it will look like a parallelogram, because it's not looking like one. But if it will take me time, I will leave it. Let me leave it, Jerry. Good. So just know that what I'm trying to say, you are in class, is that both of them are equal. Like this side as well is also 3 Newton. That's what I'm saying, trying to say. And here as well is also 6 Newton. Do you understand? Right? So here as well is 6 Newton. Here as well is 3 Newton. If you understand what I'm trying to say, give me a thumbs up. Like it can be a faint line, but they are just the same thing. Beautiful. So this is your parallelogram law, and that this place will give us the resultant. Then this angle here, the angle between the resultants. Hosanna, now I'm asking a question that requires thumbs up. You're not giving me thumbs up. That'll be your own thumbs up. All right. So the other that's actually so the angle between the resultant and one of the vectors. Are you seeing it now? It can be this one. It can be this one. But most probably want us to give us the one that's the angle with the horizontal. So this angle here gives us the direction of the resultant vector. Why this guy represents what? The magnitude. Does that make sense? So here, this angle here gives us the direction of the resultant vector. While your R is equal to the magnitude of the resultant vector. All right, guys. That said, let's now look at the properties I want you to know about a parallelogram before you can be able to solve questions on this. Now, take note of these properties because I want you to understand. So what are those key properties of a parallelogram that we need to always remember? So let's hope I'm going to draw better now. So let's say we'll have this, right? Now to make it better, it should be this way. We'll have this, then we'll have this, then we have a tiny line that covers it through. We'll have this. Then we have this, right? So it might not be perfect, but then just take it that way, my people, right? So we have, there's a line, this angle here, there's an angle here, there's an angle here, there's an angle here, and there's an angle here. Are we together? So let's call here, this is our A, here be our B, here be our C, here be our D. Now, it's important that you take into account that of the following. And what are the following I want to take account of? That A is equal to D, and that C is equal to D, which is that opposite angles of a parallelogram are what? Are equal. Right? So the next one I want to take note of, these things I'm saying now, it will help you. So you have that A plus B is equal 180 degrees. Now when I start solving, you start asking me questions. I'm giving you the key things that we need to solve questions on it. Is equal to 180 degrees. What does that tell you? That the adjacent sides adds up to 180. They are supplementary. So adjacent angles of a parallelogram, they are what? Are supplementary. When I mean supplementary, I mean that they do what? They add up to what? 180 degrees. Does that make sense, guys? Good. So these are the rules that we'll be needing for what we are doing. But then remember that we are actually going to have a line. Remember, I'm going to have a line demarcating them. Is that not so? I'm going to have a line, and that line adds out our resultant vector. But I don't want to put that line at the moment because it will confuse us. So these are the properties or the qualities of a parallelogram. So opposite angles are equal. Adjacent angles are the what? They are what? Supplementary. Now, what's the next thing I want to talk about? Remember that, let me copy this. Right? I think I didn't copy everything I want to copy. Good. This works now. So let's copy this guy. And then, that said, there's something I want us to understand here. From here, I'm going to form the cosine rule. I'm going to form the cosine rule from here. Now, look at this. Look at the cosine rule. That's the next one I want to talk about. I've given you a hint about your parallelograms. Now, I want to talk about your cosine rule. Now, for your cosine rule, use this image. Remember that in a triangle, if you know two angles, if you know at least, let me put that word there. If you know at least two angles and a side in a triangle, you can make use of your cosine rule. So the cosine rule is used when I know at least two angles of a triangle and then one of the sides. Yes. If I have, no, not two angles, two sides and an angle, sorry. If I know two sides and an angle, I can make use of what? A cosine rule. And that angle is what we'll call the included angle. If I have an included angle, that means an angle between two sides. I go again. If I have an angle between two sides of a triangle, I apply the cosine rule. I am saying all of these things so that by the time we start solving case 3 and case 4, it will make sense. I've highlighted our parallelogram law and I've given you the properties of your parallelogram. Now I'm trying to talk about your cosine rule. And I said that we use cosine rule when, for this case now, when I know two sides of a triangle and then an included angle. What do I mean by included angle? Look at this triangle here, men and brethren. Now, Let's call here our capital A. Here be our capital B, and here be our C. Now, if I know this angle here, right? Now, remember that this side is going to be our small c. If you can still remember your triangles very well, here is going to be my small b. Now, if I know this, look at this. This is a particular side of the triangle. This is a side of the triangle. This is a side of the triangle, and there's an angle between them. So when you have two sides of a triangle and an angle between them, that angle is what we call an included angle. Which means an angle between two sides. So when this happens, you can apply your cosine rule. And your cosine rule is simply saying, right, that then I'm looking for where, let's say I'm now looking for my small a, this side. It says that your a squared, or let me rearrange so that it will tally with whatever thing you've seen before now, so that people will not be confused. This is capital C now. Let this be my small c. I want you to tally whatever thing you know before now. So this is capital B, or whatever thing you'll be seeing any other place. This is A. Now I'm looking for the small c. It says that c squared is equal to what? A squared plus B squared minus 2AB cos C. If you've seen this formula before, give me a thumbs up. Good. Now, but what I want you to realize now, for this thing now, for these vectors are about to solve now, if that is this one I wrote down is if the angle is acute. Are we together now? For this one, if the angle is an acute angle. Someone asked me, someone among you asked me this very question, and that is what's her name? Mesoma, and she's not here now. She asked that sent the image to me on WhatsApp, and I dropped a voice note for her, but she's not here now. So I wish she was here. This will make more sense to her. So if that angle, if the included angle is an acute angle, that's it. Let me put it there. If the included angle is an acute angle, sorry, this is not making sense here. So let's rewrite very well. If you are still following me and you understand what I'm saying, can you give me a thumbs up? All right. Only one person. Confidence, are you still here? Okay. You want me to call your name first? I will start arresting you people very soon. I will start arresting all of you very soon, one after the other. All right, now, but what if, Susan, you joined late, you are giving me thumbs up. May the Lord grant you understanding in Jesus' name. You understand it, okay? Just what you need to do, have you eaten this morning? I didn't say that with you, Hosanna. My hands are not there. Confidence will soon come for you. Okay, you've not eaten this morning. Okay, Susanna, what you need to do now, go and eat so you understand. Once you eat, you can come back to class. And you joined late, that's why. There's nothing I can do, right? So always join early, okay? When you join early, it makes things easier for us, right? Yeah. All right. So the next one now is that it's going to be a plus, yeah? If the included angle is what? Is obtuse. When I'm greater than what? Than 90. Are we together, guys? Greater than 90, obtuse. Okay, don't worry, so I'm fine. If every student will be like Hosan, like Susan, then there will not be problem. Whether the student understand or not, they are fine. I shouldn't worry. Thank you. All right. So if the angle is an acute angle, you make use of the first one. If it's an obtuse angle, you make use of the second one. Now, why are we stressing ourselves about all of these things, right? Why are we stressing ourselves? Now, remember that we spoke about this guy, our parallelogram, right? Coming out of this very place. We spoke about this parallelogram law, right? So look at why I'm killing myself trying for us to see a link between the two of them. Now, look at how cosine rule comes in to find the resultant vector when the angles are inclined, right? Take note of all of these things. These are the oracles you'll be needing for your exams. All right. So let's paste that very formula. Good. So now observe this, men and brethren. This is a parallelogram. Now, but remember that I've actually explained regarding the angles obtainable from your parallelogram. So we've actually indicated something that if you imagine here, there's an angle here. Is that also? And that angle here will be equal to the angle here. And the angle here is as well going to be equal to the angle here. Now, pay attention. I want to break out something from that very place regarding finding my resultant. When I know two sides of the triangle and an included angle. Now, I want someone to tell me in this. Okay, let me not get to that point yet before you people wound me now with answers, incorrect answers. So let me respect myself. I believe in you guys, don't mind. I believe in you guys. I believe in you guys. I know I've wasted so much time. All right. Then I'm joining here to here. Now this is my resultant R. Remember we had an arrow right here indicating our 3 Newton. We had an arrow right here indicating another one. So permit me to change these values. Okay, let's leave it at 3 and 6. Right? Any answer it gives us is entirely fine. So let's reduce to 3 and 4, right? So that we'll not run into crisis when solving. So this is 4 Newton. All right. So remember that here represents your 3 Newton. Here represents your 4 Newton. Now you can see that there's an angle here. That angle happens to be the included angle I'm talking about. Have you seen how we formed? If you've actually seen how we formed a triangle from that parallelogram, give me a thumbs up. From the parallelogram law, if you've seen how we formed a triangle that requires cosine rule, give me a thumbs up. Yeah, justice is there. Good. Who again? Hosanna. Thank you. Who again? Paul. Well done. Ferami. Well done. Chinonso. Well done. Oh yeah, confidence is time. If you don't understand, give me thumbs down like this. Titiola. Titiola, Confidence, and Susan. All these women of Jerusalem don't even know. Confidence, you understand it? Good. Susan Oya. Susan, do you understand? Oh, okay, you're eating already. Sorry. Titiola, are you there? Headache is worrying me. Your problem plenty. Go and eat now. You're hungry. The hunger comes with headache. Leave a parallelogram law. May your head no come out. Go and eat. Titiola, are you still here? All right. So that said, you could see how we formed a triangle from our parallelogram law. I'm eating, sir. Oh, sorry. If you've eaten, receive healing in Jesus' name. That headache is gone. Right? If you don't doubt in your heart, the headache is gone. All right. Amen. Hosanna, are you sure you're not mocking my prayers? This one you shouted amen before my member that needs healing. The member that needs healing, I have not shouted amen. You are shouting amen on her behalf. All right. So we have 3 and 4 Newton here, and that's the resultant. So you will see that there's an angle here. This angle here is an included angle. Are you seeing it now? So this is your resultant. You will see that, thank you. You would see that there is a value there. You can link to that thing we wrote before. You will see that if I'm looking for R now, that resultant vector, that r will now be equal to what? 4 squared plus 3 squared minus 2 times 4 times 3 cos what? Theta. Now I'm using negative if theta is acute. Now I'm going to use r equal to 4 squared plus 3 squared plus 2 times 4 times 3 cos theta. If theta is what? Theta is what? If here I have what? Acute. If theta is less than 90. And here, if theta is what? Obtuse. Does it make sense, guys? Observe this change in sign. Does it make sense? Give me a thumbs up if you understand what I'm saying. So you've seen how from our parallelogram law that we formed an angle, right? Taking it from our what? Parallelogram law. You see the way I brought out a particular angle. Now let's see something practical. I will do it two ways. I will do when the angle between them is obtuse, and when the angles between them is, come again. It will be, I will come again in the next class now. Our next class is to be next week. Hosanna, so that should come again to be next week now. Is that not so? Is that what you mean by come again? Like next week now, right? The last equation. The last equation. Okay, so let me come again then. Now look at what I'm saying, guys. Remember that this triangle now, you can apply cosine rule on this triangle, right? Because it has two sides and an angle between them, which we call an included angle. Two sides and an angle between them. You could see that vividly, that there's an angle between them. So when you have two sides of a triangle and an angle between them, you make cosine rule. Now, observe very well that there's an angle between them. Now, this angle is facing this side. You are looking for this very side of the triangle. That side facing that angle is what we have outside here. But remember, we should have arrow squared here and arrow squared here. Now, observe the changes in sign. That's where I want to draw your attention to, the changes in sign. It is minus if the angle between them is an acute angle. If that angle is less than 90. Now, but if the angle is greater than 90, observe what happens in the sign. Actually, this is not how to teach this thing I'm trying to teach now. Like, there's a rule behind this. Because when you have cos 60, will give cos 120, will give you a negative sign. But I don't want to use that pattern. Some of you will be confused because I know that there are people that don't, like the last time we did mathematics was when you wrote YX. So I'm trying to accommodate everybody and I'm trying to use the shortest routes possible. So that the only thing you need to remember is acute and obtuse. That is all. And the negative sign is coming before the positive. Acute is up, obtuse is down. So I'm using this so that it makes the work easier for you. Do you understand? So all you need to remember is that I need to only find the angle between two sides of the vectors. When I do, there's an angle between them like this, and it forms a triangle that I can apply my cosine rule. So at every point in time, we want that angle to look like this, that there are two sides of what? The vectors, and there's an angle in between them. If you now understand what I'm saying, give me a thumbs up now. If you understand what I'm saying. Hosanna, thank you. Beautiful. Confidence. Confidence, what's the question? Confidence, what's the question? See me see problem from this woman of Jerusalem. You gave me you gave thumbs down. I'm asking what the problem is. You don't want to tell me again. If you have to go now. Sir, my head is. Oh, you can leave the class. This is a classroom. I'm not a doctor now. I studied chemical engineering. I'm not a doctor. Class and go and sleep, and then take a paracetamol as well. So sorry about that. Okay, Suzanne, you are free to leave. You go and rest. Sorry. I wish I'm a doctor then, but then if I start wishing, just you can leave the call. Okay. So sorry about that. I'll check up on you after the class. Okay, so that's what we have right here. So minus this and this. So obtuse and then acute. All right. So that said, we've actually seen how this whole thing works. So let's look at an example. And let that example now be that you have that two angles acting Let's get a question and solve. Let's say we have something like this, right? I've given obtuse and you've seen how we make use of those things. Let's say we can get the magnitude based on our cosine rule. Now let's imagine that we have a vector drawn like this. An example. Let's say we're inclined at 180 degrees, right? Or let's say 45 degrees. Two vectors inclined at 45 degrees to each other. Now, let's have the first vector this way. Let's have the second vector this way. Now, remember that we can complete it as always, right? We can complete. Let's have this way. And let's have this way. Yeah, this one is better. So now, remember that the angle between them, right? These are the two. You know, I'm just confused, right? They are that angle each other. Let's say the angle and two vectors. Let's say that we have 3 Newton for this one, and this is the direction. And let's say we have 4 Newton for this one, and this is 45 degrees. Let's just assume that this is what we have. Does it make sense now? Now we want to find the resultant vector. This diagram might not be perfect. This is now 45 degrees should be like this way. So please let me draw something that when somebody's eye sees it, it will make sense a bit. Yeah, this is how 45 should be. 45 should look like this. Yeah, do you agree with me now? This makes more sense. So let's say we have 3 Newton here, and let's say we have 4 Newton right here. That's the angle between them, 45 degrees. So we'll have this one pointing this way, and we'll have, let's say, this guy pointing this way. Now, the angle between them here is 45 degrees. But then let's complete our parallelogram. Remember, parallelogram law? Let's complete it. So we're going to have this one going this way, and then we're going to have this one going this way. Does that make sense now? So here is 45 degrees. Now, what do I want us to see here? Remember that the opposite sides, and then you're looking for your what? You are looking for your resultant. Remember that the resultant is going to pass through here this way. If you understand up until this point, give me a thumbs up. This is your resultant. If you understand up until this point, give me a thumbs up. All right, beautiful. So that's your resultant vector right there. Now, but you can see that, are you seeing any place where we can apply the way it is looking now? Are you seeing any triangle yet? Are you seeing any triangle yet? The way it's looking now. Are you seeing any triangle that we can apply cosine rule yet? No, we are not seeing any triangle yet. So, but then remember that here is as well 3 Newton. This side as well is still 3 Newtons. Right? Here as well, this side of the triangle is still 3 Newton. Right? So look at what I'm going to do for those that will read this thing later. So let me make it in a way that it will make more sense. Good. So let's have solution. I want to be careful so that anybody going through later on towards the judgment day will not be confused. So now solution, I'm going to include the parameters that we need, right? So that we can actually find the resultant. Now look at this, my people. Look at this. Now I've included my R and everything. And I've said that this side as well, that the direction right here is going to be what? 3 Newton as well. Now, observe this. Remember what I told you, that opposite angles, they are going to be what? Equal. Now, remember something very important. And what is that thing very important? Remember that that this is the included angle between these two guys. Do you agree with me? That place is the included angle. And now remember what I explained to you. If I put here to be A and here to be B, here is my theta now. There's an angle, included angle between those two sides now. In as much as they're acting as 45 degrees to each other, but it doesn't look like a triangle that I can apply cosine rule. Right? But now we formed it and it looks like a triangle that we can apply cosine rule, so we can find our resultant. Now, that being said, observe something that A plus B is equal to 180 degrees. Did you accept this? Give me a thumbs up if you remember this when I said this, that the adjacent angles of a parallelogram is equal to 180 degrees. Thank you, confidence. Titola, are you still on this call? I'm consigned. I'm worried Titola is not following for a long time, or she just joined the call and slept off. So A plus B is equal to 180 degrees. So that A is equal to what? 45, right? So plus B equal 180 degrees. So that B is equal to what? 180 minus what? 45. And what would that give us, brethren? So that B is equal to what? 180 minus 45 degrees. That should give us 135, right? Good. This kind of class here, I go play, I go score, I go defend. All the wing and me they play am. Oh, wahala. So that this small bread I ate this morning, everything will leave my stomach. So that B is equal to 135. There, that's theta. So what does that tell you? They've actually obtained that very triangle, and the triangle looks just like this. Sorry, that's not what I want to take. Okay, since I've copied it, that's fine. You now have a triangle that you can apply your what? Your cosine rule. And it looks exactly like this. I hope nobody is confused. No, I took the wrong thing, guys. So it will look like this. Oh boy. Yeah, good. So here, this place can go. Here can go. Here can go. Here can go. Here can go. Right? This side can go. This 45 can go. You will see that you now have something like this. You have an angle radius here, and that angle you have here is now what? 135. So with this, 135, is it obtuse or acute? 135 obtuse or acute? 135 obtuse or acute? Okay, forward. Obtuse. Okay, you guys should answer. Imagine you're the person teaching. I'll ask the question twice before you guys will respond. Is it that you guys hear me after 5 minutes? Maybe if I say something to hang on the air, then after 5 minutes it gets to you people. I don't even understand. So now we have that very formula. I'm looking for R is going to be R squared. Since it's obtuse, we are adding because cos 135 will give us a negative number. So this will give us what? 4 squared plus 3 squared. Since it's obtuse, plus 2 times 4 times 3 cos by what? 135. Now we have that R squared is equal to 4 squared is 16 plus 9 squared plus 2 times 4 is 12. 12 times, what am I saying? 2 times 4 is 8. 8 times 3 is 24 cos 135. So that R squared is equal to, anyone with calculator should help us. But in the absence of that, let me use my own calculator. Because I don't trust you guys. The point system now will be a problem. So 16 plus 9 plus 24 cos 135. So that will give me, are we here? Brethren, that will give us If you are following, let me know, please. Okay. So what do you have? Am I the only one punching? Do we have another person punching? Another person? Okay, good. So when we do that, we'll take the square root of everything. That's square root of 8.02. Okay, plus 2 times 4 is 8 times 24. 24 cos 135. So what's your final answer, my bro? So I have 16. Another, I want you guys to punch this, not only me doing this, so that you guys will be. Are you not? You guys are not following. If you have your calculator with me, you punch. If you don't have, you let me know. I don't want to be the one solving and also putting the values in. So okay, 8.029. Is it? Did you take the square root? Did you take the square root of r? Remember, you have r squared. Yeah, 8.029. But remember, we have it's not just r. We are looking for r squared. So you have 8.029, right? 8.029. But we're looking for r. Remember. Oh no, 2.83. Then wait. Let's use. I think. Let me check something quickly. I'm coming. Let's quickly check something. Now, solve this one now. Use minus there. I want to check something quickly. I think there's an error somewhere. Use negative sign there. I want to check something quickly. Now, like perform this for me. Let me put r. I have r squared. I want to check something quickly. Square root of everything. Use minus there. I want to check something. If this work for obtuse and acute, then there's no need of us stressing ourselves. I want to check something real quick. So let me check again. Let me use 45. Let's check something real quick. Because 45. I want to check something real quick. 4 squared, 3 squared. And this is cos 45. Okay. So what do you have? Anybody giving us the value?
Minus 41.97.
Huh? Who is saying that? 41, but take the square root. 41.9, so take the square root. Good. Thank you, Paul. 6.48, right? So radius is equal to 6.48 Newton. Now there's something else I want to verify quickly. Hosanna, are you confused? Okay, let's take it step by step. Paul, are you there? So Paul, give me the value you had before the square root so they can follow along.
Minus 41.
No, it's not. It can't be minus. No, I
It's
disagree.
41.97.
41.97. Then you're looking for R. Good. You now take the square root. So 41.97. So that will give us what? 6 point.
6.48.
Good. Now you're talking. Newton. Yeah, good. Are we on the same page? All of us, same page. If you're on the same page, all of us, give me a thumbs up. Yeah, thank you, Paul. Another person. Confidence, are you there? Confidence, are you there? Good. All right. Good. So now, There's a mistake I made somewhere here. Please pay attention to that. That error is in my signs, please. Man is getting old. So this place for acute should be plus, please. Here should be plus. So sorry about this brutal error. And I know the class is recorded, so somebody will not go there. That's why if you are watching recordings, watch to the end. Watch to the end because there might be errors somewhere in between. Sorry about this. The end card disappoint. Look at what I said. Why I said that. Okay, let's go the other way around. Now, if you don't want to use this my pattern, you remember I had to figure out what that angle is there. 135. 135. So imagine I want to go straight up. Let's say I want to go straight up with this 45 degrees I have in between here. In as much as, pay attention, you cannot see how it forms cosine, right? You cannot see how it forms. Yes. Just change the sign, right? If you check, you cannot see how I formed cosine rule from this triangle. If you want to use why I went through this test of forming this triangle, so that you can see how the triangle actually forms a triangle that we can apply cosine rule. Do you understand? I have to go through this stress, cosine rule. So you can see how it forms your cosine rule following the triangle. But if I'm in the exam hall and I don't want to waste this time here, right? I could just use this straight up, this angle here straight up, 45 degrees here, 3 Newton, 4 Newton. Angle between both of them is 45 degrees. I will go straight up. Look at what I will do now. Remember what I said. If it is acute angle, we are using what? Plus. If it is acute, 45 is less than 90. So it's an acute angle. So less than 90 is a plus sign. Yes. Look at why I said so. Now, if I want to use straight up, based on that angle they gave us, 45, without stressing myself to form the triangle that I will apply cosine rule, I want to use it straight up. Look at what I will do now. Remember the angle they gave us was 45. So I'm going to do that. Someone can punch this, men and brethren. So you see that we should arrive at the same answer, guys. All right. So I'm going to do 4 squared plus 3 squared, acute less than 90 plus 24 cos 45. So puncher, give me the value, Paul. Paul, give me the value. What will this give you? Now I'm working with r squared now is equal to. Confidence, you can punch, and if the Paul is not punching.
I'm working on it, sir.
Okay. Don't use your head, though. I say you should use calculator. Yeah, 41.7. Hosanna. Thank you. Then if you now take the square root of r, what will it give you? It will give us the same thing. What? As what? 6.48 Newton. Did you see what happened there? Did you see what happened there now?
No.
Did we see what happened now? Can you just give me a thumbs up? Did you see what happened now? Good. Did we see what happened now? Hosanna, thank you. Did you see that? If you don't want good, I just went through the stress of showing you how the triangle is formed. Susan, you're having headache. What do you want me to do? Sister? So if I did that to show that, yes, you can actually form that triangle that looks like where you can apply cosine rule. But once they tell you that a particular case inclined at an angle, if two of them are inclined at an angle, you can just go straight up and use that angle, but put into account when it is acute and when it is what? Obtuse, right? So that said, another thing is, how do you now find the angle between them? So magnitude now. This one is for magnitude. This is for magnitude. So remember that R represents the magnitude. So magnitude, the magnitude R is equal to 6.48 Newton. Now, we now want to find the direction or the direction. And I told you the direction has to do with what? The angle. Now, look at this. Pay attention to what we started with, right? Now, when we drew this, remember, we introduced our resultants. Remember, we introduced our resultant. This is our resultant here, right? So there's an angle between this resultant and one of those guys, which is our horizontal. And that angle is this angle here. Men and brethren, please follow me. Follow me. Follow me. This angle here. This is the resultant. So we're looking for this angle here. Let's call it theta 2. That theta 2 what is the angle between the resultant and one of the what? The vectors, the one in the horizontal. So that theta is the direction you are being asked to find. That theta is the direction. So what will you do? This is where we apply our sine rule. So what does that tell you? It simply tells you that for this our question now, yes, of course, you've calculated your resultant. Let me take this triangle now. Let me take this triangle now. So the next one now is for your what? The next is your what? Sine rule. We use sine rule for doing what? Calculating what? The direction of the vector. If you're with me, give me a love emoji now. If you're with me, a love emoji at this point. If you're with me at this point, thank you, Osana. Thank you, Paul. Thank you, Confidence. Thank you, Ferrami. Suzanne, the Lord will help you. Don't worry, you understand it. Eze, you're not we're answering the same surname, you're not giving me a love emoji. When you are joining this the next class, why join you? Remove that surname. Okay. Cos 45 should be 1/2. Good. Cos 45 should be 1/2. Yes, I think it's been so many years I wrote jam now. People that I wrote of recent, the calculator has cos and sine, Abi. It doesn't. No. Okay. I know. Sure. Okay. Now it has. You have your special angles. That's why you should go and learn about your special angles. Learn about your special angles. Yes, learn about your special angles. Now, cos 145, cos 45, cos 45 is 1/2. Is it 1/2? Go and search about special angles. Search for your special angles. √2/2. Yes, special angles. It should be √2/2. Meanwhile, they will give you questions that will not require. Remember that these ones I'm solving now, I'm just giving you the concept. So the kind of angles they will give you is one that will be like angle 60, 45, 90. All those special angles. You know about your special angles, right? You know about your special angles. Good. So all those ones that require 30, sine 30 should be 0.5. Cos 30 should be √3/2. Cos 60 should be 0.5. That's 1/2. Sine 60 should be √3/2. One of them should be 1/√2 or √2/2. So just go and learn about your special angles. Google it. Special angles. Now that table is a table you should know for your special angles, right? So calculating the direction of what resultant vector. I'm just trying to give you a heads up of how the whole thing looks like. So now look at this very thing. Now, how do you calculate the direction of result? But the angle they will give you will be actually these ones I'm solving is more technical, right? Is to make your whole work easier for you. So the ones they will give you will be much. You can use your special angles for it. All right. So I'm saying that now we are looking for the angle between the resultant vectors. So that said, let's have this. Now there's an angle here. This angle is what you are looking for. Let's call it theta 2. Now this is when you apply your sine rule. Now what does sine rule say? Sine rule says that if I have a triangle, sine rule said that if I have a triangle, we have A, B, and C. So you have an angle here, you have an angle here, you have an angle here, right? So here facing here is small c. This side facing here is small a. This side is small b. So what you are going to do, you said that sine A all over what? Small a is equal to sine big B all over small b Go and learn about your special angles actually. Sine C, that's why you're a student. All over sines over small c. All right. So that said, I'm going to apply that to this our equation now. You could see that we have this place. We have resultant. Resultant vector now is equal to 6.48 Newton. So you have three sides already, 1, 2, 3, and an angle. So you are looking for this particular angle. That means the side facing here, right? So if I'm to number it, you're going to see that here, if I'm to number it, what I'm going to do now, I hope I'm not confusing us. I don't know why I'm feeling somehow that some of us, if a good number of us are not confused, Abby. Hmm? So let's apply, good. Let's apply the sine rule to it. Obasi, are you with me? Titiola. Titiola is sleeping, my God. And she was the first person that joined class, only for her to end up sleeping. That's very bad. Okay. So let's apply the sine rule now. So I'm going to have sine 135. I know the value, sine 135. Don't worry, the kind of value they will give you is one you can actually apply your special angles on it. Is that okay? I'm just giving you a background. Later I'll start solving questions on that. Sine 135 all over 135 is facing here. So I'm going to have 6.48 is equal to, this angle is facing 3 Newton. So I'm going to have sine theta 2 all over 3 is equal to, hmm? It's okay. I can just use that too because you cannot use three of them at the same time, just two to compare them. Is that okay? So with that, I can find the angle between them when they are acting at 40 degrees. So that means I have that 3. That means I have that 3 sine 135 is equal to 6.48 sine theta 2. So I'm going to divide both sides by 6.48. Normal mathematics, 6.48. So when I do, I will have that sine theta 2 will be equal to what? 3 sine 130, sorry, 5 all over 6.48. But like I said, they will give you special angles. They will give you special angles. So sine theta 2 is equal to, they will give you special angles, okay? During my own time, when I wrote JAMB, what I did was to train myself not to be using calculator. And it's really helped me. Because that calculator, by the time you move your cushion to calculator and come back, time is going. So I was even faster than using that calculator. It really helped me back then. So train yourself on that. So theta 2 will now be equal to sine inverse of 0.327. So shift, but they will not give you something that will take you this kind of angle. I'm giving the difficult one so that it will be easier as time goes on. So that will give us 19 degrees. So the angle between them is going to be what? 19 degrees. So to get the angle between the resultant vector and one of the vectors, you use your sine rule. And remember, this is for only when the angle is inclined at an angle. When it is inclined at an angle, right? When it is inclined at an angle. So that's the process that we actually follow when you are looking for the resultant. So they say the angle between them is 45 degrees, angle between them is 60 degrees. Always remember, you can use them directly. If they give you 45 degrees, you can use directly into the cosine formula. I just have to show you how it came to be. So, but remember that 45 is accurate. They give you 120, use it directly into the formula. Just that we don't need to start proving that adjacent angles, add them together, gives you this and that. Now, having said that, you've seen that I've applied cosine rule. So this implies that for case 4, vectors, two vectors inclined at an angle, use cosine rule. use okay, no, before I say this, example 2. Let's consider a case. Let's consider two vectors inclined at 90 degrees to each other. So let's say we have two vectors inclined at 90 degrees. Remember, I'm talking about the cases where they are inclined. So if you have two vectors inclined at 90 degrees, let's say I have 3 Newton here. Let's say I have 4 Newton here. They're inclined, the angle between them what is 90 degrees. Now remember, as always, you're going to form your what? Your parallelogram. Please follow me, brethren. Are you still with me? There's an angle here and there's an angle here. So now if they're inclined at 90 degrees, so let's find the resultant vector. So as always, let's copy this guy. Let's form our parallelogram, right? Because anytime we are dealing with those cases where it is inclined, we'll make use of our what? Of our parallelogram law. So let's apply parallelogram law here. I want us to see something, guys. Let's apply parallelogram law to this, to that very right angle triangle. Let's apply it. Now, if I apply my parallelogram, I'm going to have something like this. Let's complete it. It's going to look like this. Then we have resultants this way. These are resultants. Is that not so? These are resultants. So now, and I told you, anytime we're applying angles are inclined, we use our cosine rule. So let's apply cosine rule here. So remember that the angle here is 90 degrees, angle between them 90 degrees. So let's go straight to apply our cosine rule immediately. So what will happen here? You're going to have that r squared is equal to 3 squared plus 4 squared. That is 90 degrees. 90 is not really acute, but let's apply that as acute angle here. So minus acute is plus, Abi. Acute is plus, right? Is that not so? Acute is plus, guys. So let's continue. So plus 4 squared, yeah. So plus 2 times 3 times 4 cos 90 degrees. So that r squared will be equal to 3 squared is what? Is 9 plus 16. Are we there? Plus 2 times 3 is 12. 3 times 3 times 2 6. 6 times 4 24. Cos 90 is 0. 24 cos 90. Cos 90 is 0. Is that okay? Cos 90 is what? Cos 90 is what? Is 0. You should know all these things. 90 is a special angle. So that r squared will now, you are now left with, let me just continue with 3 squared plus 4 squared. 3 squared plus 4 squared. 3 squared plus 4 squared. So this will be plus 0. So that r squared is equal to 3 squared plus 4 squared. Did you see what happens? What happens is that this side is now ruled out. Who can tell me there's a formula that this thing looks like? There's a formula that this thing here looks like. Who can remember? Anybody here that can remember what this r squared, 3 squared plus 4 squared represents in mathematics? Anybody who can guess? That formula reduced from cosine rule to a particular rule because this part of the equation now turned to 0. So you now reduce this to Pythagoras theorem. Thank you, Paul. Beautiful. So now this now gives birth to what? To a Pythagoras what? Pythagoras what? Theorem. So this now gives birth to what? Your Pythagoras. Pythagoras theorem. Do you know what it tells you now? That was what gave birth to what? To case 3. So when angles are inclined at 90 degrees, there's no need solving cosine rule. Use your Pythagoras theorem when the angles when the vectors are inclined at 90 degrees, if they are acting perpendicular, if they are perpendicular, I mean 90 degrees, we apply what? Pythagoras theorem. Then if they are not inclined at other angles, at angles other than 90 degrees, apply your what? Your cosine rule. But if they are acting in the same direction, we add together. Opposite direction, subtract. Inclined at an angle that is not 90 degrees, cosine rule. But inside cosine rule, remember, acute, you add at the center. Obtuse, you subtract. But once that angle is perpendicular or acting at 90 degrees, you use Pythagoras theorem. Does it make sense, guys? Is it only Paul that is following? Hosanna, good. Confidential confidence. Good. I think you're enjoying this confidential confidence I'm calling you. You always want me to call you that. I'll stop calling you. Don't worry. Justice. Justice. Justice for the last time. Are you in class? Ferrami, are you following? Ferrami, following. Right. So everybody's on the same point now. So now, in summary, then another question now is, since our resultant, let's go ahead and get the resultant vector now. So we have that R will now be equal to square root of what? 9 plus 16. R is equal to square root of 25. So that R is equal to what? 5 Newton. Good. I like that voice. Meanwhile, I cannot hear Stella's voice again. So you're like 5 Newton. So magnitude. Magnitude of resultant vector. I think she slept. She's tired. Of resultant vector. Thank you, Ferrami, for that. God bless you. Equal to what? 5 Newton. Now, how about the direction now, or the direction as the case might be? So for the direction now, for direction is very simple if you are acting at 90 degrees of resultant vector. Now, remember, let me see. People that can remember their Sokatua, right? Now I have this. How do you get the resultant vector now? So if they're acting at 90 degrees, there's no need using sine rule. You don't need sine rule. You only do that if they're not acting at 90 degrees. Now, who can remember? Now, let me remove here. I'm looking at the angle between this resultant and here. There's an angle here. Now we have that the resultant is equal to 5 Newton. So now we have a right angle triangle. The right angle triangle is like this. We'll have this. We'll have this. We'll have this. Here is 90 degrees. Remember that here is your 5 Newton. Here is your 4 Newton. Here is your 3 Newton. We are looking for this angle here, which is theta, which is the direction, angle between one of the vectors and the resultant. Remember your Sokatua. Sokatua says that sine theta is what? Which one is your opposite? This is your opposite, right? Let me just put it in bracket now. Good. Ka. This is our opposite. This is our hypotenuse. This is our adjacent. I'm looking for this angle. So the one that connects both of them is what? Is not cow. So the one that connects the both of them is what? Is toa. It connects the one that connects these two. You can use any one actually, right? But it's advisable that you make use of those two vectors. Make use of those two vectors they give you. Don't make use of the resultant vector. Make use of the two vectors they gave you. Make use of the two vectors they gave you to look for the angle. So that angle now is going to be tan theta is equal to, our opposite is what? Opposite is 3 over adjacent equal to 4. So that means that theta now, theta is equal to tan inverse of what? 3 over 4. So theta is equal to 3 over 4 is 0.75. So you are looking for the tan inverse of 0.75. So that's it. But like I said, they always give you special angles, like 0.5. Tan inverse of 0.5 should give us okay, infinity. Maybe they always give us something that we can actually relate with the angles. So tan inverse of 0.75. That will give us 37 approximately 37 degrees. So you've seen that all of these things have shown me that they are confidence. Are you here? Confidential. Do you understand it now? Justice, do you understand what I did? Paul has left. Paul, are you still here? Anointed. How far? I didn't know Anointed was still on the call. Like, Anointed, are you still here? Or you've gone for anointing service? Have you gone for anointing service? Anointed? Anointed is no longer here. Good. Anointed, are you following? Are you following at all? Anointed, are you following? Okay. So now, what are the conclusions we can make from here now? So conclusions we can make. Oh, you're in a public place. Okay. But are you sure you are following in that public place you are? Are you sure you are following? Be sure you are following. So for case 3, two vectors acting at 90 degrees. That is perpendicular to each other. So to find the resultant, in brackets, magnitude, we use what? We use what? Pythagoras theorem. Then for direction, of the resultant, you use you use SOHCAHTOA. And in particular, I use tan theta, tan inverse of y over x. Now, for case 4, two vectors inclined at an angle. Two vectors inclined at an angle. So you use what? Two vectors inclined at an angle. You use for the resultant, which is the magnitude. You use what? Use cosine rule. So note by acute. Remember that acute is what? Acute is what? Is positive, right? That's less than 90. Obtuse, negative. That's for what? For resultant. Then for the direction, apply the sine rule. Use the sine rule. It's clever. It's clear now, right, everybody? It's clear now, right, everybody? Good. So these are the cases for your angles, right? Case 1, case 2, case 3 have been tackled. So in summary, Titiola, now you are coming back. Titola, tell me, just be sincere. Have you been following? Unmute yourself. Titiola. All right. So we started our class. We're talking about scalar and vector quantities, right? We said that scalar, they have magnitude and they have magnitude only. We'll give examples of them. We went ahead to talk about vectors, and we spoke about how we need two things to describe them, right? So we went ahead to speak about vectors and how we can represent vectors, right? And I said that the length of each line gives the magnitude. And I spoke about resultant vector, a single vector that can actually represent all the vectors acting on an object. So after that, I now looked at how can we get these resultant vectors, which we call the resolution of vectors. So we said that we can look for it. Case one is you have two vectors acting in the same direction. Case two, Suzanne, you can listen now. It can help you as well. Listen now. So case two, when two vectors are acting in opposite direction, and then case three, when they are at 90 degrees to each other. That means when they are perpendicular to each other, right? And I showed you, I actually proved how to show that they are 90. So actually, 3 and 4 can be meshed together using one single terms when they are inclined at an angle, because even when they are at 90 degrees, they are inclined at an angle. And I showed you why we now have to treat this guy as a special case using a knowledge from case 4. If you saw that when I did that, give me a thumbs up. When I actually showed that, yeah, case 3 is also inclined at an angle, but we have to break it down into case 3 because there's something special about it. If you saw that is special about it, can you give me a thumbs up? If you were here when I actually showed what was special about case 3, can you give me a thumbs up, guys? Good, Paul, thank you. Paul, you saw it. Who again saw that special case? Confidence, thank you. Who again saw that special case? Justice, did you see that very case? Something special about case 3. Are you sure you saw it? This one I called you and I'm giving me thumbs up. Ferrami, Ferrami, right? Are you sure you saw it? Turn on your mic.
Yes, sir.
You know, when people are lying, I will know. That voice is sounding like you just lied. The sound is
No,
somehow.
sir. No, sir. I'm just a little bit sick.
Okay. Justice, turn
Okay.
your mic and answer. Did you see it, Justice? You know, when there's this sound, when somebody's lying, there's how the voice sounds. Like, I will not tell you how it sounds, but I know that there will be a little change in the voice. All right, so case 3 was actually similar to case 4, but there's something different about it, right? So they are all inclined at an angle, but at 90 degrees, you're going to see something. So we looked at acute angle when it is less than 90 and up to when it's also greater than 90. Because even this case 4 can also be when it is what? Equal to 90 degrees. Are you seeing that? When it is equal to 90 degrees, it's also part of case 4. So this is when it is what? Equal to 90 degrees. Then we went ahead to show something. Case 1, when they are acting in different direction, I said add them together. That's for your case 1. Now, case 2, when two vectors are acting in opposite direction, I said you should do what? Subtract them. Now, for case 3 and case 4, I said that for us to understand case 3 and case 4, that we need to learn about parallelogram law, cosine rule, Pythagoras theorem, and what? And sine rule. I introduced your parallelogram law, and I said that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, that the diagonal is going to give us what? The diagonal will give us the resultant vector. Now, having said that, I drew a diagram and I gave an example, and I said that this diagonal from the center is your resultant vector. Why this angle between the resultant and the horizontal, that's one of the vectors, will give you the direction of the resultant vector in the x-axis. Do you understand? Resultant in the x-axis. Now, if you get this part, you can as well get this part. This is also resultant vector, theta 2, theta 1. But this one will not be what? In the y what? Axis. Does it make sense now? If you just, that's when I added now. I didn't remember to add it. But if you understood what I just added now, can you signify by giving me a thumbs up? So the angle with the 6 Newton is resultant along the x-axis. Then theta 2 resultant along the y-axis, which can as well be calculated. All right. So that said, These are the properties of a parallelogram. I was trying to show you something, but this is not really necessary in example, right? So with that, I want to show you how those angles came to be, how we can apply cosine rule to your parallelogram. That's why I had to show you these rules, right? And I showed you that cosine rule can be solved using this included angle and the rest of them. And after that, we solved an example and we brought out that triangle and formed a triangle from a parallelogram and showed how you can apply cosine rule to that triangle that was formed. And after doing that, and I said we can have the acute, right, which has plus, and the obtuse that has a negative sign, depending on what you have in terms of the angle. By the way, acute angle less than 90, obtuse angle is greater than 90, but less than 360, right? But greater than 90, less than 180. So now we have two vectors inclined at 45 to each other. Now look at the way it looked. They were inclined at an angle. That was how it was looking when they were inclined at an angle. But I cannot see anything here that looks like where I can apply my cosine rule. That's why I have to teach you how to use your parallelogram and the properties of a parallelogram. So ahead with that, and you saw something very unique. We have to form the parallelogram law, apply the parallelogram law so we can have something, right? And from there, I know how to apply the properties of a parallelogram so I can actually form a triangle from that parallelogram. And when I did, we now had this very triangle. And with this triangle, we could now apply what? Our cosine rule, because the triangle now looks like what we can apply cosine rule to, right? The parallelogram now looks like something that we can apply cosine rule to. So after that, you could as well see something very beautiful, that I got the magnitude to be this. And when I decided to use that angle that was given to me directly, in as much as that very parallelogram did not look like what I can apply cosine rule, but it showed you that it is possible to use those values directly. You just have to pay attention to what happens to this. When I use my normal triangle, I have cos 135 because there's a connection between angles. Cos 45 is the opposite of cos 135, more like in sine. If you check it, cos 45 will give a particular value. Cos 135 will give you the same value, but one of them is going to have a negative value based on quadrants. Quad, so first quad, second quad, third quad, fourth quad. That thing is coming from your limit. But I showed you the can into but I don't want to go to that place because some of us are not writing maths. But those writing maths will understand better. So I now said that for us to sine rule to find the direction of the what resultant what vector, and I showed you how to use your sine rule. Then after everything, and I said, let's consider a case where the angle is 90 degrees. It is not acute, it is not obtuse, it is equal 90 degrees. And with that case, we applied our cosine rule, and then we saw something very interesting. That cosine rule will reduce to what? Pythagoras what? Theorem, where you have c squared is equal to a squared plus b squared. And that was what gave birth to what? To case 3. Right, let me use black here so that in case the quality of the video reduces. So this is c squared equal to a squared plus b squared, Pythagoras theorem. So we said, should in case, right, we now have at 90 degrees, there's no need of applying cosine rule. Apply your Pythagoras theorem to get the magnitude of the resultant vector. Anytime two vectors are perpendicular, perpendicular means 90 degrees, right? And how can we get the direction of the resultant vector? I had to apply SOHCAHTOA to it. SOHCAHTOA was used to find the direction because there's no need using sine rule because you have a right angle triangle, right? And after that, and then gave us a conclusion that for case 3, if they are perpendicular, we'll make use of Pythagoras theorem to get the resultant. Direction, we'll make use of SOHCAHTOA. And remember, you can have direction in the y-axis, direction in the what? X-axis for your resultant vector. Why am I saying this? When I will start teaching you resolution of more than 2 vectors, we'll be resolving in the x direction and in the y direction. So resultants, and that is exactly what we have right here. Any question, guys? If we are all on the same page, or if you understood everything we did today, can we have a thumbs up as we come to the end of the class? Thank you, Paul. Thank you, Titiola. Thank you, Justice. Yeah. Okay, beautiful. So guys, yeah, thank you, Ferami. So that's it. In our next class, I'll be solving questions, and while solving the questions, I'm going to also look at resolution of resolution of more than two vectors. So after that, and that will be on Friday. Actually, there's no class on Friday, but because I want us to finish everything on vectors, I'll be fixing a class on Friday morning by 10 a.m. so we can finish everything on vectors, right? Resolution of vectors and then solving questions on that. So by upper week, we enter a new topic. So I wish you guys all the best. Ensure you visit this video again if you're confused, right? And always remember I'm right here for you guys. And it's my desire to come to different schools by this time next year for convocations in different schools. That's my desire. That's my goal. And that's what I want to see by next year. I wish us all the best. Ensure you are reading. Ensure you are paying the price. And eventually, the Lord will bless the work of our hands. All right, guys. Peace out. Hope you enjoyed today's class. Yeah, thank you. Titiola, message me after now. Let me be sure you follow this class. Anointed, well done. Anointing, well done. So let's take attendance. Eze was. I said, message me after now. Eze, anointed, Paul. Eze was in class. Anointed was in class. Um, Titiola was in class, Susan was in class, Justice was in class, about 9 of you. All right, so Mr. Hillary will come to the end of the class. Thank you so much, guys. Meanwhile, for mathematics, I'll upload your mathematics classes very soon. All right, peace out, everyone.